All right, welcome to The Explainer. Today, we're diving into a concept that could seriously shake up the future of unmanned aviation. This isn't just about a new aircraft design, it's about a whole new way of thinking about flight. So let's get right into it.
So first things first, you see this incredible machine? Well, it's not actually flying through the clouds. Not yet, anyway. It's a concept, a really powerful vision of what could be coming next in aviation. And that, right there, is what makes it so fascinating. Okay, so if this thing isn't real, what are we even looking at? What's the big idea here? Right. This is the MRN-X7. Think of it less as a finished product and more of a conceptual framework. A big what if for a seventh-generation unmanned aerial vehicle, a UAV. And the name itself gives you a massive clue. Monterrey Negra, that's Spanish for Black Monterey. And just look at it. You can totally see that inspiration in its blended wing-like body. It's the perfect parallel from nature for a design that needs to be both efficient and sneaky. So the whole idea behind this thing, its entire philosophy, is built on 5 key pillars. Okay, so this slide basically lays out the DNA of the design. You've got low observability, which is just a fancy way of saying it's hard to see. Then there's aerodynamic efficiency. It's got to fly for a long, long time. And then you get to the brains of the operation, intelligent autonomy. All its parts have to work together perfectly, and it needs to be modular so it can be adapted for all sorts of different jobs. These 5 things are really what define the whole concept. Yeah, let's really dig into that intelligent autonomy piece, because this is a total game changer. We're not just talking about some fancy autopilot here. We're talking about an onboard AI that can literally manage the flight controls, figure out the best route on its own, and even change its mission on the fly based on new information. That's huge. Okay, so we get the why. Now let's pull back the curtain and look at the how, the actual anatomy of this concept. And this is where that big, bold vision starts to look like real engineering. This blueprint shows how those abstract ideas, stealth, efficiency, are translated into actual lines and curves. Every single part of this schematic has a very specific purpose. So how do they pull that off? Well, it all starts with that blended wing body, where the wings and the main body are just one smooth, continuous shape. And you'll notice there are hardly any vertical surfaces, no big tail fin sticking up. That shape, plus using super lightweight stuff like carbon composites, is the key. It makes the radar signature tiny, and it cuts down on air resistance. That gives it a really high lift-to-drag ratio, which in plain English just means it can fly a really long way using a lot less energy. I love this comparison. On the left, you've got the slick, artistic vision, and on the right, the hard-nosed engineering blueprint that makes it all possible. It's literally the bridge between what if and how to. So let's break down the 2 biggest benefits here, side by side. What's so cool is that the very same design choices that make it stealthy are the ones that make it super efficient. That flying wing shape, those smooth surfaces, they're great at deflecting radar waves, but they also happen to be perfect for slicing through the air with almost no effort. So it can stay up for a really, really long time without guzzling fuel. So what are they actually aiming for in terms of performance? This table lays out the conceptual targets. Now, these aren't exact numbers, but it paints a really clear picture. It needs to fly for a very long time, cruise super efficiently just under the speed of sound, fly way up high, and do all of that with a serious level of autonomy. All right, so we've got this stealthy, super efficient, intelligent concept. The big question is, what would you actually do with it? What kind of missions are we talking about? Well, the potential applications are just incredibly broad. Because it can stay up for so long, it's a perfect fit for things like long-range environmental monitoring or atmospheric studies. You could also use it as a kind of flying lab to test out new aerospace tech and AI systems. And of course, a stealthy, autonomous platform like this, well, it obviously has some pretty clear strategic and security applications too. This picture is really important. Seeing the model right there on display, it reminds us what this is all about right now. It's a physical conversation starter. It's a framework that lets engineers and planners get in a room and really hash out what the future of unmanned flight is going to look like. Okay, let's pull back for the big picture. Beyond the awesome design, why does a concept like this really, really matter? Because this is way more than just one cool design for an aircraft. It's what you'd call a convergence point. It's a roadmap that shows exactly how stealth, artificial intelligence and cutting-edge aerodynamics are all starting to merge into one single incredible system. Honestly, this is where aviation is going. And the source material just nails it when it calls this a visionary reference point. It's like planting a flag in the future that researchers, engineers, and strategic planners can all look to and say, okay, that's what's possible. And all of this brings us to one final, really big question. This isn't just about the technology itself, but about what it all means. As these aircraft go from being simple tools to intelligent partners in the sky, how is that going to change our relationship with flight itself? Definitely something to think about.